Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate
Let's solve another rational equation. So again, the first thing I need to do is check out my denominators and find any restrictions. So take your denominator, set it equal to 0, and solve. In this case, I have one restriction. Now under 9 is just a 1. Now what we're going to do is set up our proportion and do the inverse operations. Now, 5 is being divided by x minus 4, so I'm going to multiply by x minus 4 on both sides. Now remember, the reason we did that is because these two quantities, x minus 4, will simplify, not cancel, to 1. And then we can isolate the left side and move the variables to the right side to solve. Now notice I wrote x minus 4 in parentheses. That's very important here. Here's why. Do you see as I rewrote this, do you see I'm going to need to use distributive property here? What can happen if you don't write parentheses is you can forget or miss that distributive property, and then that's going to lead you to the incorrect solution. From here, I'm going to do distributive property and solve my equation all the way to the end. Now remember, once you get your solution, check it against your restriction. Our restriction was x can't be 4. That's not 4, so now I know this is my final answer. In this rational equation here, you'll notice that this denominator also has a variable. So what this means is, when we try to find our restrictions, we have to consider both denominators now. So the first thing I actually want to do in this case is see if I can factor this, and it looks like I can. Now you may be wondering, Stevenson, why'd you factor this? Well, we don't need common denominators for our equation here because we're just going to do a cross product because this is a proportion. However, when I go to factor this, it'll make my solving much easier for my restrictions. So let's do that next. So remember, with our restrictions, we take each denominator, whatever it is, set it equal to 0 and solve. Now, in the case of 5 over x, that denominator was an x, so as soon as I set it to equal to 0, it's already solved. It's pretty sweet. Now on this one here, we have a product, so we're going to use our skills we did with factoring with our quadratics and use zero product property. So you're going to see I have x equaling 0 as one of my restrictions and x equaling 1. Okay, so here's my proportion. All I did was just rewrite it. Here are my restrictions. X cannot be 0 or 1. So now we're going to do our cross products, or essentially our inverses. Now, here's the thing though. Normally what we've been doing is just doing one side because only one side had a variable denominator. But in this case, both of them have it. So I suggest doing one at a time. So you can see in this first step here, I multiplied by the inverse of this. 6 is being divided by the x squared minus x. I have it in factored form. I did its inverse, which is the product on both sides, so that simplifies to 1. And now this is what I have. What I'm going to do now is do the same thing with the single x. This quantity up top is being divided by x, so what I'm going to do is now do the inverse operation of multiplication on both sides. Now, at this point, I want to do distributive property on the right, combine like terms, and solve for x. Now, this is a quadratic, so remember with quadratics, we want to move everything to one side. So since my x squared's on the right and it already has a positive coefficient, I'm going to go ahead and move everything to the right. Okay, at this point in my quadratic, what I'm going to do is factor it and figure out what it is in factored form because that'll be super easy to find my zeros. Now that it's in factored form, do zero product property again. So now you can see I have two answers. Now remember, we had restrictions though, right? So let's go back up to the top. X could not be 0 or 1. Well, wait a minute. We got 0 in one of them. That means we have to exclude it. It can't be one of my answers. That means 11 over 5 is my only answer here.